10, section 2, parallel lines. So this is still the geometry, very important knowledge you need to know. You know, here we have two lines. One is called line AB, another is line CD. So we call their parallel. That means they will never intercept each other. They keep the distance between these two lines always same. So we use this sign, means they are parallel. Okay, parallel to each other. We use this sign, means they are parallel to each other. Okay, use a parallel line. We can also solve a lot of problems. Now let's see here. Let's see who can help me read this. Brian, can you help me read this problem? 10.9.
Okay. Draw a pair of parallel lines like these shown below. Then draw a line that crosses both of the parallel lines. With a protractor,
yes.
Protractor, measure all the angles formed between your line and both of the parallel lines. Write the angle measures and the angles you formed. Try it again with a pair of parallel lines. Do you notice anything interesting?
Yeah, say here they give you the two parallel lines, right? Then they ask you to draw another line intercept with these two lines. Then you can say here how many angles you get after you draw this line intercept with these two parallel lines. You can say you will get 8 angles. Now let's mark these angles. You can say, suppose this one's number 1, this one number 2, this number 3, this number 4. Then here this one number 5, number 6, number 7, and number 8. You got this 8 angles here, right? Among these 8 angles, you can use a protractor to do this experiment to measure that. Later, definitely you found angle 1 will equals angle 3, will equals angle 5, also equals angle 7. Probably this angle, I can imagine it's about 60 degrees. If I draw here, then angle 2 will equals angle 4, will equals angle 6, will equals angle 8. This will equals 120 degrees. Okay, it's for this special case. And also you can say angle 1 plus angle 2 will equals angle 3 plus angle 4 will equals angle 5 plus angle 6, and also equals angle 7 plus angle 8. This will give you 180 degrees. Okay, so now let's see, based on that one, how we can solve this problem. So everybody send me your answer in the private chat. What is say here we have two parallel lines M and N, then another line intercept with MN, then they form 8 angles here, right? This 4 angles here, another 4 angles. Then they give you this angle equals 35 degrees. Then they ask you what is the measure of all other angles. Okay, Joyce, A, that's correct. Then you can write down all of them. What is angle B? What is angle C? What is W, X, Y, and Z in order? Then let me check. Okay. See, yeah, Joyce, you're correct. Okay, Brian, BXY. Yeah. Okay, correct. Joyce, Brian. And let's see, Justin, A, B, C, W, X, Y, Z. Yeah, Justin also correct. Rebecca, correct. Yes, see, this 35 degree, B that's also 35, X and Y also 35. You can write this. So B, angle B equals X equals Y, this one equals 35 degree. Then the A equals C equals W equals Z, this one give you 145 degrees. Okay, very good. Now let's see this problem. Let me see. Eric, can you help me read this problem 11?
Okay, so a chicken starts at point X on one side of the road. It starts walking across the road along a path that makes a 22-degree angle with the side of the road, as shown. Before making it to the other side, the chicken makes a sharp turn at point B and starts along a new path, which makes a 71-degree angle with the old path, as shown. If the opposite sides of the road are parallel, what are the measures of the acute angle that the path of the chicken makes with the far side of the road at point C?
Okay, so this problem tell you, suppose a chicken start from this side, walking, try to pass through this road. The chicken arrive point Y, the angle here that's 22 degree. Then the chicken suddenly make a change, the path go this direction, this angle that's 71 degree. Then later they ask you, what is this angle equals? What is this chicken's path form an angle with other side of this road? What is this angle equals? So everybody try this, then send me answer in the private chat. Okay, Joyce, you are correct. Who else? Rebecca is also correct. So now let me ask Rebecca, can you explain to us how you get your answer? Rebecca, are you there? Can you explain how you get your answer? Joyce? Joyce, can you explain how you got your answer?
I just split the road there between at this angle where the 71 degree is, and then it's those are 49 and Z is at a 49 degree.
Okay. So this problem, actually the key point is draw additional line. You know, this additional line, you have 3 ways to draw this one. You know, one way, you can draw this way. Extend this line here, intercept with this line at this angle, because they told you this two sides of this row, they're parallel to each other. So that means this line parallel with this. Then we can get this angle equal this one. This should be also 22 degrees, right? Then in this triangle, suppose this point is W. In the triangle WYZ, you know this angle that's called external angle of this triangle, external angle of this triangle. Then we know this angle should equals 22 plus this one. Suppose this one is x. X plus 22 should equals 71. This based on external angle. We know because this angle as external angle should equals x plus 22. This is one way to draw this extension line, addition line. Another way, you can draw this one. You extended this one here. Suppose they intercept with this line at W. Then you get a triangle XWY. Then you can say this angle, that's external angle of this triangle. So therefore, this 71 equals 22 plus this angle. You got this one 49, but because this line parallel with this one, so the angle we are looking for actually is equals x. So then that means this x equals 49 degrees. This is the second way to draw this additional line. Another way, you can draw this way. You can draw another parallel line pass through the point y. Okay, you can draw this way. Then you got this line parallel to this one, because this one parallel with this. So these three lines will parallel to each other. That means this angle will equals 22 degrees. Then this one will equals 49 degrees. But this one will equals this. That's exactly what we are looking for. So therefore, this angle also equals 49 degrees. Okay? So in geometry, try to draw additional line. That's very, very important. So this problem, if you don't draw additional line, it's hard to calculate. Maybe from the intuition, you feel just use 71 minus 22, then you got the answer, but you maybe not really understand why you should do that way. But after you draw this additional line, then you understand, oh, that's a correct way to do that. Now we finished this section. Now let's go to next section. This section we will learn the angles in polygon. So first, now let's say what is a polygons? Polygons, that's a simple closed figure consisting entirely with the line segments. So pay attention for this definition. A polygon, that's a simple closed figure consists entirely of line segment. So here you need to pay attention for the three keywords. First one, closed. If it's not closed, definitely it's not polygon. Okay. Then all the edge should be line segment. If you have some side is not line segment, that should not be a polygon. And also simple. So that means you should not get the cover the two different edges, two different area. Now based on these three keywords, now let's check which figure here is polygon. Say this first one, that's a pentagon. This one, each side, that's a non-segment, right? It's closed, and also they just form this region, so that's fine. This is a polygon. This one also that's called quadrilateral. That's four sides. This one, 1, 2, 3, 4, 5, 6. That's a hexagon. Correct. That's also a polygon. This one, no, because this one is not closed, right? This one, no, because this side it's not line segment. It's a curved. It's an arc. So this one is not polygon. This one, not polygon, because this one is not simple. They form these two regions, right? Even all the sides are line segment and also closed, but the figure they formed, that's not a single region. They formed the two regions, so we don't consider this a single closed figure. So this one is not polygon. Okay. Now let's see. Here we have some concepts here. Each line segment we call the side of polygon, and the connection of any adjacent vertices. You know, each point we call the vertex. Connect any two adjacent vertex we call the side. If you connect the non-adjacent vertices, we call that one diagonal. So here, like AB, AF, that's called sides. AE, this one we called diagonal. Okay. Then interior angles, that means these angles we called exterior angles. Okay. If you extended, remember, if you extended this line longer, this angle we'll call the exterior angles. So all these angles called interior angles, but this one called exterior angles. Now here then we have names for each different sides of polygon. If we have 3 sides, we call it triangle. If we have 4 sides, we call it quadrilateral. If we have 5 sides, we call it pentagon. If we have 6 sides, we call it hexagon. You have 7 sides, we call it heptagon. Have 8 sides called octagon. 9 sides called nonagon. 10 sides called decatagon. 12 called duodectagon. Okay, so I think most you need familiar at least the first 4. That's triangle, quadrilateral, pentagon, and hexagon. Okay, now let's say use this. What do we example problems we can solve? Let's see here. They ask you use a protractor to measure each angle in these 3 triangles. If you have a protractor handy, you can measure that. Then send me answer in the private chat. If you don't have, you can just estimate. Now let's start from this triangle ABC. Give me the angle A, angle B, and angle C in order. What is the measure of each angle A, B, C? Usually, for the angle, we use this sign, means measure. Then we use a capital A, this capital A, to represent this angle, that's equals 90 degree, okay, 90 degree. Then angle B, I guess this one should be 60 degree, okay. Angle C, that had to be 30 degree, okay. Now, let's say triangle TUV, then angle T, I guess this one's a equilateral triangle, that's equals 60 degree, and also equals angle U equals angle V, this equals 60 degree. Now let's try to measure angle ZXY. So for angle Z, I guess this one should equals 120 degree. Looks like this angle X should equal 30 degree. So angle X, and also looks this side equals this side. So angle X will equals angle Y will equals 30 degree. 30, 60, then plus 120 should be equals 180 degree. So then you can notice all this, whatever the shape of a triangle, okay, the sum of their interior angles, okay, that means inside of these three angles add together always equals 180 degrees, right? So suppose this one's 30, 30, this 120, always equals 100 degrees. I know most of you probably already know this fact, but do you know how to prove that? How to prove why that's always equals 180 degree? So in this problem 13, they will teach you how to prove this. To prove this, you can just draw a parallel line from any vertices. Suppose the triangle we have, that's ABC, right? You can use any point like A, B, or C. Draw a parallel line to the opposite side. So if you start from A, you draw a parallel line DE parallel with BC. Okay. Brian, we already learned this chapter?
Yeah, I remember we were like going to do area, I think.
Let's see, Joyce, we already finished this chapter?
Yeah,
I
think.
If we already finished this chapter, now let's see, we can go to next chapter. I remember we, okay. So, so which section we should go?
This one, but like the
Oh, yeah, I remember
an
now.
area one, but we like haven't started it yet.
We have not started the area.
Yeah.
Okay, so then now let's start from this. Okay, I'm sorry. Okay, so for area, you know, that's you use 1 by 1 square to fill a figure inside of figure. You know, see here. Suppose we try to calculate area of this rectangle, this square, right? For any shape, suppose if you try to calculate area of this, then you use a 1 by 1 square. Say each side of this square, that's 1. You use this 1 by 1 square. We call the unit square. We use this unit square to fill the shape the figure we try to measure. Suppose we try to measure the area of this rectangle, so then you use a unit square to fill this inside. Say how many this kind of square you can fill here. Suppose we can fill this one, then the 2, this 3, then this 4, 5, 6. Then say later, if you are lucky, right, you can get exactly the integer number of this unit square filled in this figure. But most of the time, definitely you're not so lucky. You probably cannot fill next what I show here. We fill 6, but we still has this kind of region not filled, right? So then you can still try use this, probably say here, because this is too short. Then we can separate this square as these 2 parts, put one here, then put another one here, then have this left. So then you can count, that will be 1, 2, 3, 6 plus this one 7. So it will be about 7.5 square the area. Suppose this one's each one is like centimeter, right? So this one was 7.5 centimeter square, right? So that by this way I can explain what is area. Area just use the 1 by 1 unit square to fill a region. Then what is the number of unit squares you can get in this region? Okay, so most of the time you will get a decimal or fraction, right? Because the figure maybe not so exactly can filled with a unit square. So now let's see example here. Say in this problem number 6, 11.6, they give you PQ equals 4 and the QR equals 9. Then they ask you calculate area of triangle PQR. Is everybody, can you send me answer? What is the area of triangle PQR? Okay, great. Eric correct, Joyce correct, Justin correct. Yes, this one you can just use, if you know the formula for the right triangle, 4 times 9 divided by 2. This is one way. If you don't know this area formula, you can still calculate this area. Why? Because say if you have another triangle put here, they will form a rectangle. This rectangle area, that's 4 times 9, that's 36. And these two triangles are congruent. So then that means area of triangle PQR will equals half of 36. So that's equals 18. Okay. So now let's go to number 7. This one tell you in a right triangle, the legs, that's the 2 sides of the triangle that form a right angle. Suppose angle of a right angle have the lengths of A and B. Find a formula for the area of the triangle in terms of A and B. This one, that's can everybody write down that formula to calculate area of a right triangle if you know these 2 legs equals A and B? Suppose this one is a right triangle. Okay, suppose this side equals A, this one equals B. Then they ask you the area of this right triangle. That will equals A times B divided by 2. Yeah, Joyce, correct. Because from the previous problem, you can see here we can draw another triangle here. Then this will form a rectangle. Then this rectangle, this side that's A, this also B. Then the area of this rectangle will equals A times B. Then these two triangles are congruent. That means the area of this one triangle that equals A times B divided by 2. Okay, so now let's go to number 8. So this one, now let's see who can help me read this one. James, can you help me read this problem?
Ravi and Ranu are trying to decide how to paint a rectangular wall that is 18 feet long and 8 feet high. Ravi wants to paint a right triangle as shown on the left below. Ranu wants to paint a more interesting triangle like the one shown on the right.
Okay, so here they ask you A, what is the area of the region that Ravi want to paint? So what is the area of this triangle? So they give you the width of this, the height, they call height, that's 8 feet, right? The length, that's 18 feet. Then they ask you, what is the area of this triangle? Everybody calculate this. Okay, James correct, Joyce correct. Who else? Rebecca is correct. Justin correct. Yes, this one equals 18 times 8, then divided by 2. So this one equals 72 square feet. Okay, very good. Now, B. Divide the wall with Ranu's triangle into 2 rectangles such that the painted portion of each rectangle is a right triangle. What is the area of the region that Ranu's want to paint? So they ask you, what is the area of this triangle? Okay, this one also equals 72. Why? Because base still 18, height that's 8. So the shape, this area still that's 72. Okay? So these two triangles, even their shape is different, their area that's same. Okay. Now they ask you continue this one, number 9. Say, use your observation in the previous problem to describe how to find the area of any acute triangle. Say this one, it's an acute triangle. Yeah, maybe this angle looks like close to 90 degrees. Okay, let's suppose that's less than 90 degrees. Then, based on what you observe here, how to calculate the area of any acute triangle. So that means if we have this acute triangle, how calculate this area? To do that, suppose you choose the base, okay? You choose the side as the base, then you need to draw attitude. Suppose this base, this is A, this is a height H, then the area of this triangle that's equals, usually base we use B, that means base. So it's B times H, then divided by 2. This gives you the area of this triangle. Suppose use A to represent area of this triangle. Use base times altitude divided by 2. So then now let's see next problem. Number 10. Now let's see. Justin, can you help me read number 10?
Ravi and Renu are expanding their house so that the wall that was 18 feet by 8 feet before will become 28 by 8 feet. Ravi still wants a triangle that reaches from one corner to the opposite corner, but he doesn't want to use any more paint than he used for his triangle on the old wall. Renu says they'll just keep the bottom of the triangle the same and extend the top of the new corner as shown below. Is Renu correct? Does Ravi need the same amount of paint for this triangle as he needed for his triangle in problem 18.8?
Okay. So anybody give me your answer? So the question is this new triangle still also have the same area with previous two triangles? Yeah, Rebecca, you're right. And Justin also right. James, you need a double think. So you can think, what is the base of this triangle? What's the altitude of this triangle? You can say the base of this triangle, that's, you can use 18 as base. So 18, the height, that's even it's outside of this triangle, but the height still that's 8. Then divided by 2. So the area of this triangle still equals 72 square feet. This base, this is the height. Then divided by 2. So the answer for this one is yes, it's correct. They have the same area. That would mean they need the same amount of paint for this triangle. So now let's say number 11. So Joyce, can you help me read number 11?
A median of a triangle is a segment that connects a vertex of the triangle to the midpoint of the opposite side. For example, in the diagram on the right, AM is a median of ABC. Show that a median of a triangle divides the triangle into two pieces with equal area.
Okay, say M is a middle point of BC. So we use this little tip to represent BM equals MC. Then AM will call the median of the triangle on side BC. Because M is middle point. If you connect A and M, AM will call the median of the triangle on side BC. Then they ask you, say this AM will separate this triangle ABC as two triangles, that's ABM and AMC. Now they ask you to explain why these two triangles have the same area. Okay, this reason, because they have the same base. If you draw the altitude from point A to this side, this height, suppose this is AD. This AD, not only its altitude of the triangle AMC, it's also the altitude of triangle AMB. Therefore, say the area of triangle ABM, this one equals BM times AD, then divided by 2, right? Then area of triangle AMC, this one also equals MC times AD, then divided by 2. So because BM equals MC, you know, BM equals MC because M is middle point of BC. So therefore, this one you can use BM to replace. So BM times AD divided by 2, right? So therefore, this one equals area of triangle ABM. So that means the area of these two triangles, they're same because they have the equal base and share the same attitude. Okay, therefore these two triangles have the same area. Okay, so any media separate the triangle as two equal area triangles. Now let's say 12. This problem, say Tina wants to carpent a room that has an unusual shape shown on the right with solid lines. Each darted square in the diagram has a side length 5 feet. They ask you, what is the area of Tina's carpet? Everybody calculate this. Say, what's the answer? Send me answer in the private chat. They give you, okay, they give you each for each square, each side that's 5 feet. Okay, 5, 5, 5, 5, 5. Okay, 5, 5, 5. This also same. Then they ask you to calculate this area. Everybody do this.
Everything on the bed, it's messy. 这些都不用。我要知道这个是干的，不是要下来。
Okay, so Rebecca looks correct. Who else? Say this one, you have 2 ways to do this. One way you can use subtraction. Another way use addition. Okay. If you use subtraction, you can do this way. Now let's calculate this triangle. This one, that will be this side, that's 15, right? Here that will be 5, 5, that's 10. 10 times 15, then divided by 2. So this one, that's equals 75. Area, that's 75. Then this one, that's 1, 2, 3, 4, that's 20. 20 times 10, 200 divided by 2, this is 100. Then that's calculated this rectangle, that's 1, 2, 3, 4. That's 20 times 5. That's 100. This 1, 2, 3, 4, right? 20 times 5, 100. Then calculate this area of this triangle. That's 1, 2, 3, 4. Yeah, 1, 2, 3, 4. Then times this 5. 4, that's 20, right? 4 times 5, 20. 20 times 5, that's 100. 100 divided by 2, that's 50. So then that means each, now let's count this 1, 2, 3, 4, 5, 6, 7, 8. 8 times 5, that's 40, right? 1, 2, 3, 4, 5, 6, 7. So that's 7, that's 35 times 40. By this way, you get an area of this big rectangle, okay? That this way you get a 1,440. 20, 1,400. So this 20, yeah, that's 1,400. Okay, you got this. Now we need a minus. We need to use this one. Minus 75 minus 100 minus another 100 minus 50. So then you can calculate this. That's 200. 325, so you got a 1,075. Okay, this we use a subtraction. Okay, we do this way, calculate the big rectangle area, then minus this triangle, this one, this small rectangle, and this triangle. This is one way. Another way, use addition. If you try to use addition, you need to do this way. Separate this shape. Let's do first one. You can draw a line here. I think we can draw here. We can draw here. Then this one is a triangle. Then draw here. This part, that will be a rectangle. Then this one, make this one longer. Then draw here, this will be another triangle. Then here, that will be another triangle. So that means you need to do this way. Okay, let's do this. So here, you need to calculate area of this triangle. This one, that's 10. This one, 15. So that's 150 divided by 2, that's 75. Then the area of this rectangle, that's 15 times 10, that's 150. Then the area of this triangle, that's 10 times 1, 2, 3, 1, 2, 3, 4. That's 20 times 10, then divided by 2 is 100. Then the area of this one, that's 50. This one, that will be 1, 2, 3, 4. That's 20. 20 times 10, that's 200. This part, that's 1, 2, 3, 4, 5. That's 25 times 1, 2, 3, 4. 25 times 20, that's 500. So then that means the area that's equals 500 plus 75 plus 150, then plus 200 plus 100, then plus another 50. This way you also will get a 1,075. Okay? So you can use these two ways. I feel use subtraction a little bit easier because that outside the shape is have fewer. If you use inside, then you separate to more small pieces. But anyway, you still can get the same answer if you do it correct. So then we finished this section. Now let's go to next section. This calculate the area, okay? Then for circles, circle is a little bit more interesting. How to get a circle? A circle, you need has a central point. Usually we use called compass to draw a circle. You use 1 foot of the compass as a center. Then you have the distance between these 2 feet of the compass as a radius. Then you turn that one around. Then we'll draw a circle. So for any circle, you have a central point that's called a center. Then you have a radius. So here OA and OB, they call the radius. So usually we use R to represent radius of a circle. Then AB we call the diameter. We usually use D to represent diameter of a circle. Then you can say the diameter equals 2 times radius. Okay, so D equals 2 times R. Then for a circle, usually we concern what is if we walk along the full circle, what is the distance we passed? That one we call the circumference. Circumference. Circumference, usually we use C to represent. C equals 2 times pi times the radius. Or you can write this one equals pi times diameter. So here pi, that's a very special number. That's equals 3.14159 blah blah blah. This one is will never repeat and also will never stop. So this kind of number we call the irrational number. Irrational number. Because relative to this kind of number that we call the rational number, that means we can write a number like P over Q for. Okay, this kind of number we call rational numbers. But for the irrational number like pi, root 2, e, all this kind of number, you cannot write the number as P over Q for. So that's the reason we call this the irrational number. Then we also care about what is area of this square. No, not square, circle. Area, usually we use A to represent, or use S. So A, that's used more. So area, that's equals pi times R square. Okay, if you try to use diameter, that would be pi d square, then divided by 4. Because we can use d over 2 to represent this r, then later you square, you got a d square over 4. So this is area formula, this is a circumference formula. Now later we can use this knowledge to help us solve the problems. You can say here, this value for the pi, this keep forever and never stop, and also there never has any pattern there, never repeat. Okay, this is called irrational number. Now area formula, that's pi r square. Okay, now let's see some examples here. Rebecca, can you help me read this 13?
What is the radius of a circle that has circumference 54 pi centimeters?
Okay, everybody send me answer in the private chat. What is the radius of a circle that has circumference that's 54 pi? Okay, Joyce, correct. Who else? So here they give you the circumference, then they ask you to find the radius. Rebecca is also correct. So you know that formula I already write, that's for you, that's 2 times pi times r. This one equals 54 pi. Then you solve r. So cancel out pi both sides. Then r will equals 54 divided by 2. Get this one equals 27. Now let's see number 14. Eric, can you help me read this number 14?
If 1 gallon of paint is enough to paint the interior of a circle with diameter 10 meters, then what is the diameter of the largest circle whose interior I can paint with 4 gallons of paint?
Okay, if you use 1 gallon of paint to paint a circle with a diameter 10 meters, then they ask you what is the diameter of the largest circle you can paint with 4 gallons of paint. Joyce, double check your answer. This one is a little bit tricky, okay? Say you have 1 gallon of paint. You can paint the area of circle that's pi, because here diameter that's 10, right? So if you use the diameter formula, that will be pi times 10 squared, then you need to divide by 4. You can use radius. Radius, that will be 5. Radius will equals 5. So pi r squared, pi times 5 squared. Okay. Then you have 4 gallons of paint. How big of the diameter of the square you can paint if we use D to represent that area, that will equal this. So it's 1 gallon, you can paint this. 4 gallon, that means you can paint this one times 4. So that's pi times 5 squared, then times 4, right? Times 4, now let's try this one. 4, that's equals 2 squared. So that's equals 5 squared times 2 squared. So that means we can get this one is pi times 10 squared. 10 squared, you know, this one is the radius, okay? So that means we can use 4 gallon of paint, can paint a circle with the radius, that will be 10. Radius is 10, suppose that's r equals 10, we can get this one, get diameter will equals 20. Because diameter equals radius times 2. So why it's not equals 40 centimeter of diameter? Because this one square, it's not a linear relationship. Okay, because this diameter or the radius, that's square. You know, when you increase the radius or the diameter a little bit, then the area will change significantly. because that's area equals pi times r squared, or equals pi times d squared, then divided by 4. So when you increase radius or diameter a little bit, then the area of the circle will increase significantly. Okay, so here the relationship between the area and the diameter is not linear. So therefore, then when you increase the diameter from 10 to 20, then the area will increase 4 times. Okay, so that's the reason the answer for this one is 20. It's not 40. So now let's see number 15. Let's see who can help me. Brian, can you help me read this 15?
Wait, number 16.
15.
My rectangular house is 30 feet by 40 feet. My goat Cassidy is outside on a 20-foot long leash that is connected to a corner of my house. What is the area of the region in which Cassidy can roam?
Okay. Everybody try this problem. This problem, part A, it's easy. Part B will be a little bit harder. Okay, let's first draw a diagram to understand this problem. Say, first they said my rectangular house is 30 feet by 40 feet. So that means like this, okay? This is my house. Suppose that's 30, this 40. Then say my goat Cassidy is tied outside my house at a collar. Suppose we tie this goat at here. The leash is 20 feet long, so that's half of this. Then they say what is the area of this goat can roam. So then you can say this goat can go here 20. This will be 20, right? Also can go here 20. So now let's suppose here that's 20. Then you can think that region will something like this. It will like this circle, right? I did not draw this perfect, but you can think this region will be a circle with the center at this point. Then this part, that will be the 1/4 of this circle. The region we are trying to looking for, that's 3/4 of this circle. Okay, you can this half, but here that will be another quarter. So how we can calculate this region? To calculate area of this, you can use radius, that's 20. So pi times radius, that's 20 squared. By this way, we get the full circle area, right? But the goat definitely cannot go inside of my house. The goat can only stay outside my house. That's 3/4 of the full circle. So I need to times 3/4 to this one. So then we can simplify. This one will be 400 pi, then times 3/4. You get this one will equals 300 pi, right? So that means area of this shaded part, that's equals 300 pi. Now, this is part A. We finished part A. Part B, now they change the length of the dish from 20 feet to 50 feet. Okay, they change this dish from 20 to 50. So that means the goat, suppose still tied here. If the goat go this side, that's here, that's 40, right? So then the goat still can go here 10 more feet. So the first, the goat probably can go here. If the goat go here, that's 40. Then go here another 10. So if the goat goes this side, that's 30. Reach this corner, then still can go here 20. Okay, suppose here. So that means, say the goat go here, that's use this one, that's the radius 10, that would be with a radius 10 circle. Maybe I can draw here. That would be this circle. Okay, you can see this semicircle, the radius, that's 10. Then we can draw here, but from here to here, that's this also 10. So we can take away this part. Okay, make this one better. You can draw a quarter of circle that's radius, that's 10. Now from here to here, that's a radius of large circle. We can draw a circle like this. That's not good. So we can draw something like this. Okay. This also should be, suppose this 20. Okay. Then here, that will be another quarter of circle with radius 20. So this 20. So this 10, right? So then you can say, now if the dish is 50, then the region this goat can roam, that will be separate 3 parts. One is 1/4 of circle with radius equals 10. Another is 1/4 of circle with radius 20. Then another one is 3/4 of big circle with radius equals 50. So then you can say this quarter of circle, that's you use pi, that's pi times 10, radius 10 square, then divided by 4. Because this is a quarter of that full circle. So simplify this, you get a 25 pi. This 25 pi. This one, that's pi times 20 square, then divided by 4. So this one gives you 100 pi. So the area of this one equals 100 pi. Now this one, that will be pi times 50 square, then times 3 over 4. So if we simplify this, you got this one, that's pi times 2500, then times 3 over 4. So we simplify this one, got the 625 then times 3, that will be 1875 pi. So the area of this bigger one, that's 1875 pi, right? So then you add 100 pi, add 25 pi, so that total will equals 2000 pi, right? So add this 100 pi, that's 1975 pi, then plus another 25 pi, that's 2000 pi. So the answer for part B should be 2000 pi square feet. Okay? So this part B is a little bit hard. Okay? Now let's see 16. Joyce, can you help me read this 16?
2 quarter circles are drawn with their centers at opposite vertices of a square, as shown at the right. If the side length of the square is 6, then what is the area of the shaded region between the quarter circles?
Okay, everybody do this. So each side of this square equals 6. Then they draw 2 quarter of circle. Use use this corner as a center, then you draw a quarter circle here. Use this one as center, you draw quarter circle here. Then you got this shaded area. Then they ask you what is the area of this shaded area. Joyce is correct. Who else? Rebecca is correct. This one, you have 2 ways to solve this problem. One way, connect this diagonal. Connect this one. This diagonal will separate this shaded part as 2 equal parts, right? So then our goal is to calculate the one equal part. Now let's suppose calculate this the right side, this shaded part. This one, definitely you need to calculate the area of this quarter circle first. That will equals pi times the radius, that's 6 squared, then divided by 4. This gives you the area of the quarter circle. Then you need a minus area of this rectangle, right? Because this rectangle, this each side, that's 6. So minus 6 times 6, then divided by 2. By this way, give you the area of this half of this shaded part. So then you can simplify this one will be 9 pi minus 18. That's half. Later you need to times this one by 2. Okay, then you got this one equals 18 pi minus 36. This is one way. Another way, you can think, imagine, probably you don't need to draw this one, but you think if you add the area of this quarter circle and this quarter circle together, then you can see this shaded part added twice. The non-shaded part only add once. Okay, so now let's suppose we separate this three region as A, B, and C. If we add area of this two quarter circle together, we add A once, B twice, and C once. So then we can write this one equals A plus B plus C, then plus another B. If we add this two quarter circle twice, two quarter circle, that equals half of the circle, right? So that's equals the full circle area, that's pi times 6 squared, right? The half of that, that's equals 2. So this equals 18 pi. This one equals 18 pi. But this one, you know, the area of, that's A plus B plus C, that's area of the square. That's equals 36, right? So then they ask you, what is B? So that means B equals 18 pi minus 36. Because the two quarter of circle, that's half of the circle, that equals 18 pi. Then this 18 pi equals 36 plus the shaded part. So therefore, the shaded part equals 18 pi minus 36. So now we finished this chapter, I believe. Now, summary. For this chapter, what we learned, the most important part, one, it's regarded to the triangle. We have called triangle equality. So this one is very important, very useful. A lot of for the triangle here, you cannot have this equal sign. That's a strictly equality. That means any sum of any two sides in a triangle should be greater than the third size. Okay. Then for the rectangle, then we have the parameter, that's formula, that's L plus long plus width, then parentheses times 2. Okay, for the triangle, the area of the triangle, that's equals base times altitude, then divided by 2. That's for any general triangle. For a circle, you know, if radius of circle, that's r, then the diameter equals 2 times r. The circumference of circle equals pi times diameter, or pi times 2 times of the radius. Then area of the circle equals pi r squared. Okay, so by this we finished the chapter 11. Then your homework, you need to finish all the exercise problem behind each section we learn, and also the review problems. Challenge problem you can try. If you like to do, you can do them. If you don't have time, you don't have to do that. Now let's go to chapter 12. Chapter 12, what do we learn? That's called right triangles and quadrilaterals. So the first section, that's Pythagoras theorem. This one's very important, very useful. Let's talk about in the right triangle. Suppose here we have a right triangle. This one. You have two sides, form a right angle. These two sides we call the leg. Then this longest side we call hypotenuse. So in this right triangle, we have a theorem called Pythagoras theorem. That is, suppose this side equals not equals A, this one's B, this one's C. Then we have A squared plus B squared will equal C squared. Okay, this one called Pythagoras theorem. Okay, we will learn this one later. Now let's see some example here. Say in this example, they give you four identical right triangles with legs of length 3 and 4 are attached to the sides of a square WXYZ as shown, such that PW equals QX equals RY equals SZ equals 3, and PX equals QY equals RZ equals SW equals 4. Then first, A, they ask you to explain why the angle PWX, this one equals 180 degree. Explain why angle PWX equals 180 degree. And why, say, PWS, yeah, this one. They ask you why this angle equals 180 degree. And why PQRS, this bigger one is also a square. B, what is the area of PQRS? What is the area of this big square? C, what is the area of this small square, WXYZ? Then they ask you to find what is WX. So this problem actually show you one way to prove Pythagoras theorem. Okay, this is one way to prove that. This problem exactly show you if you have a little square WXYZ, each side we still don't know that. You just have this one square. Then you build 4 more squares outside of this square. Attach these small squares on this small. Attach these 4 triangles to this small square. Then you got a big square. So now let's first follow these steps. First, who can explain why the angle PWS, this one's 180 degree? So to do that, you can say this angle definitely equals angle PWX equals this one plus angle XWZ, then plus angle ZWS equals these 3 angles added together, right? They already tell us this one is a right angle because they tell us this the square. So therefore this one equals angle PWX plus angle ZWS, then plus 90 degree, right? Now let's say this angle plus this angle. You can say this triangle congruent with this one, because each one is a right triangle. Okay, then this side equals this side equals this side. So these two triangles are congruent. That means this angle will equals this one, and this angle will equals this one. So in this right triangle, we know this angle plus this angle will equals 90 degrees. Because this one equals 90, right? Sum of all three angles equals 180. So therefore, this one plus this one equals 90 degrees. And this angle equals this one. So that means this one equals PWX plus PXW. Because this angle equals this angle. This one equals this one. Then plus 90 degrees. Then you can say in the triangle PWX, the sum of these two angles also equals 90 degrees. Then plus this one, that should equals 180 degrees. By this way, we proved this one that's 180 degrees. That means this one's a straight line. Okay, PWS, that's a straight line. That's also tell us all these three sides. PXQ, QYR, and SZR all the straight line. Okay, then that means they form a big square, right? Because say all this side all straight line, and each one is a right angle, and also each side equals PX plus XQ. These four triangles, right triangles, are all congruent. So that means each side are equal. PQ equals QR equals SR equals PS. Therefore, this big rectangle is also a square. Now, B. What is area of PQRS? PQRS, say 4 plus 3, that's 7. That's each side of square. Yeah, Joyce, you're right. 7 times 7, that means area of this PQRS equals 49. 7 times 7. Then they ask you to find the area of the WXYZ. WXYZ, that will equals 49 minus the area of this four right triangles, area of this triangle. Each one, say 3 times 4, that's 12, divided by 2, that's 6. Each one, that's 6. So that's minus 24, right? So 49 minus 24 equals this one equals 25. 25, you know this one's a square, right? So that means each side of this square that equals 5. So that means length of WX that's equals 5. This one's 5, 5, 5. So then you can say we got a 3 square plus 4 square that's equals 5 square. Okay? Later you can say, suppose I build this one equal each side that's C, this one's A, this one's B. So then you got A square plus B square equals C square. Okay? So by this way, we proved the Pythagorean theorem for this special case. But actually, this approach you can use to prove Pythagorean theorem. So time's up. We can stop here. Then the next time we'll continue from this problem 12.2. So we can stop here. See you next time. Bye.